All right, good afternoon. So I'm going to start off with a poll, and it'll be a little different than my normal presentations. How many people here have worn a VR headset? I imagine almost everybody. And now how many people here have been in a nuclear power plant? Really? That many? Normally I give presentations for VR and an Exelon, and nobody's ever heard of VR, nobody's ever worn one, and everybody's a very technical, mechanic, electricians, that sort of a thing. So it's a very different kind of a presentation I'm giving today. I'm going to try to avoid using all the nuclear acronyms. If you hear me say some of them, just wave your hand at me and just say, I don't know what that is. So I stole a title of VR Evangelist. Apple posted it a couple of weeks ago, and I realized that's what I've been doing a lot inside Exelon. So we'll start with a quick agenda. Who am I? What is Exelon? I'm going to go a bit over Nuclear 101, because anytime I can talk about it, I have to. I love to. I want to educate people about why it's good. The talk is about complex problems with interesting solutions. So could VR be a solution? Some of the use cases that we've already done, and then time for questions. And if you have any questions throughout, feel free to ask just anything you want to know. So who am I? I'm Carl Rytych. I'm on the Digital Plant Innovation team. My background is nuclear engineering at U of I. And the first time I ever used VR was actually at U of I in the Virtual Education Research Laboratory. This is before the Oculus, before the Vive. It had a big screen you could look at and glasses that had trackers on them, and it would control what you were looking at, and you could sort of see it in a virtual scenario. And they were exploring it, this is probably 2004, as to what they could really do with this video game environment for nuclear reactors. Since then, I started at Exelon as a site system engineer, crawling around equipment, being in high radiation zones, doing those sorts of tasks, actually at one of our power plants. And then in 2016, I joined the innovation team. On the innovation team, I say I'm a VR evangelist. I spend a lot of time showing people what VR is. I have an HTC Vive that'll bring out to our sites, put people through some of the scenarios, get their feedback, and really just teach them what it is. I'm a project manager for VR projects, help design what we want to do. Most of our actual VR coding and 3D modeling is done with a vendor, work very closely with them, and then how we actually get this training to be used by the mechanics, and that goes through a lot of our training department. So the Digital Plant Innovation team, we have a strategy. Everybody has to have a strategy for what it is. And this is going to sound very similar to a lot of the other companies here. We want to make the workforce more efficient. We want to have a transformation with cutting-edge tools, and VR being one portion of that technology stack. So it's a slide I stole, has some facts about Exelon. We are a very big company. We're Fortune 100. We are the largest owner-operator of nuclear power plants. And we also have a lot of other utility businesses, fossil power plants. We have energy trading. We're very much in electricity because everybody wants electricity run 24 hours a day, no matter what. I mean, if the lights went off in here, it'd be a really big problem. So Exelon generation, we specifically have 23 reactors at 14 locations, 13 locations now actually as of a couple of weeks ago. And we have a lot of other power plants in the power sector. I'm on the nuclear side, so it's kind of what I know and love. Now, when you think nuclear power, this is where all the power plants are in the world. You have the US, Europe, China, Korea, and Japan. A lot of them under construction in China. Exelon is only in the United States. When you start talking about nuclear power, everything is very export controlled. We don't deal very much with designs outside the US. Everything that is here has to be here. So there was a talk earlier today, they mentioned cloud computing scares people. We don't do cloud really at all. Everything has to be on-premise, and we don't do anything that could possibly expose our information to a hacker in some way. It's one of the big issues we face when it comes to anything digital in any way, shape, or form. Here are our nuclear power plants. There's a list of them mostly in Illinois, Pennsylvania, New York, New Jersey. This is all, you can go on the Exelon Corp site and you can see all this sorts of information. And now my favorite slides are, what is nuclear power? So I get to explain this to everybody here because not everybody gets to see this. Maybe you saw this kind of a slide when you were in middle school for about 10 minutes and then you fell asleep. So we take a uranium atom, we break it apart, it releases heat, we boil water, it spins a fan. It's as simple as that. But we got to make sure that nothing bad ever happens. Because if something bad happens, almost no matter what it is, you'll see it on the front page of the Chicago Tribune or the New York Times. And that's not okay. We're not allowed to have anybody get hurt. We're not allowed to have any equipment break. And if something does break, we have a backup for it. If that backup's broken, we have a backup for that. And sometimes even another backup for that. Because everything has to be uninterrupted and work perfectly safety no matter what. So those are some of the classic pictures you see if you go on Wikipedia that you see how a power plant works. It looks real simple when you have a picture there. I got some later slides that make it a little more complicated. So here's our nuclear fuel rods. This is actually what gets hot and makes nuclear power. So when you start talking about nuclear waste, it's just some metal bars. It's really concentrated. That little tiny fuel pellet you see there is a full train load worth of coal. Train car worth of coal. Huge amount of power inside this reactor. We only have a refuel outage once every 2 years. Other than that, we're running 24/7, or at least that's the goal. Other fun picture. That's actually what a nuclear reactor inside of it looks like. It glows blue. So when you're doing a refuel outage, when you're taking the old stuff out and putting new stuff in, this is actually what you see. So that's not an easy job doing something like that, making sure that everything is done properly. Because if you take one of those fuel rods and you put it in the wrong spot, it's going to throw off all your math, all your engineering. If you've never seen inside of a nuclear power plant, this is them getting ready to work on the main turbine system. This is a very large piece of equipment. And again, everything has to be done properly or else nothing works. And my favorite other picture is the cooling towers. People think, they watch The Simpsons, they see this is just a bunch of steam. Nothing dangerous at all. In fact, you wouldn't be able to tell this might be a coal plant. So there's just my favorite background. And now we get to the meat and the potatoes of this talk is what is the problem we are trying to face in Exelon nuclear? And that really is that training people is complex. And here's a list of whole issues, and a bunch of them have been mentioned before. We have a new generation of workers that want to have technology. I showed up and they gave me a paper book and a stack of paper prints. And it's like, well, this is, archaic. It works, and it's proven to work, and nobody can hack a piece of paper. So that's why they do it. They know it and love it, and it works. But you need to change. Nuclear power plants have radiation in certain areas. So you can't just walk around and go anywhere you want. There are certain rooms that they're locked because of safety issues. So if we need to plan to do a job in there or do maintenance, I've never been in there before. I don't know what it looks like. I don't know what to expect. So one of the reasons we're looking at maybe a VR solution. We have specialized maintenance. You talk about a toilet. Luckily, a toilet, you can understand how it works. That was the talk that was in here 10 minutes ago. For those new people in here, how do you do maintenance on a toilet? Well, that's pretty standard. For us, we might be talking about a $10 million piece of equipment that you haven't looked at in 10 years. Everything has to be done perfectly, no matter what. For those refueling outages, we bring in maybe 5,000 contract employees for 2 weeks. And those people have never been to the site. And they're going to come in, do their very specific task, and then leave. So that short period of time, maybe they're coming in with a skill set, but they got to be trained on the site itself. So then we talk about the cost of training. We want it to be low because training is expensive. Each of our nuclear sites has a training department. Each of those is probably 30 to 50 people. And we are constantly training our operators, our maintenance, every department we have. And our nuclear training department is an accredited program. So if we have any kind of tests, we have somebody overlooking and making sure that we're testing appropriately. Because if, let's say, there is a pump that breaks, well, why did it break? We go into a root cause analysis. Maybe the person who did work on it recently wasn't trained on how to do it appropriately. Well, it's a training issue. We should have trained them better. Now all the training for the next 10 years is going to be much better. So there's a huge amount of complexity here to make sure we're doing everything correctly. So why use VR? It was probably about 2.5 years ago, VR entered Exelon. And it was one of our training instructors. He got a small amount of money and he created one of the applications that I'm going to show you. And it's really taken off. When we created our digital plant innovation team, I took over the VR side of things, and I really wanted to show it off to everybody I could. And I've probably given the demo 1,000 different times to people. I've taken it to family days, I've taken it to everywhere I can, and put the headset on people and talked about it, talked them through some of these jobs that we can do. And there are a huge amount of benefits that we have, and I got a handful of them listed here. We're trying to simulate tasks. We want to make things safe because you're not going to get radiation dose when you're wearing a VR headset because you're not inside the plant. And we want to make things, what's the term I used here? Cost effective and unique and realistic. We want to make things memorable so that when you do go into the plant to do the real job, you know what you're doing. You may have practiced it in a training learning center with a pump, and you're actually turning wrenches and things like that, but you can only do that so often. In VR, you can hit reset, and you can try and try again. We can have 10 people all working at the same time. We can show you data in unique sorts of ways. And there's a lot of interesting benefits we can do that we're still discovering. We've been doing it for 2.5 years, and we're still learning all sorts of new cool things. Every time I give the demo to somebody, they say, oh, well, can you do this with it? Can you do that with it? The cool thing about VR is that almost always, yeah, we can. Then we kind of figure out what's the benefit to doing it that way, because we do have so many people in an accredited program, and we do a lot of lectures and PowerPoints and hands-on. Sometimes a PowerPoint is the way to go. Sometimes a good VR scenario is the best way to go. So we have a whole bunch of applications that we've made, and I'm going to go through a couple of them here. Probably won't have time to go through all of them. See, there's my acronyms already. RP technician, radiation protection. FME is foreign material exclusion. Fuel bridge operation, maintenance, security. A lot of different departments that we've shown it to. They want to do something with it. And we talk to the management teams, and they come up with a very specific use case. We scope it out. We work to create it. And then we help them to deploy it. Every site of ours has the HTC Vive. Some of them have a Vive Pro. So there's a lot of other technologies that are out there. Personally, we like the Vive. It's a lot more freeform. You can walk around a bit more. And currently everything uses Unreal. We've looked at Unity. Both are pretty good. So the future of AR, VR, I see is huge. There's so many things that we can do with VR. And we just got to really figure out what is the right thing to do at the right time. Some of these challenges we face are really, really unique, and VR is just the right way to do it. And you can practice skills that are realistic, and you can do it repeat, because repetition is the best way to learn something, on top of teaching it to somebody else. And so that's one of the things that I like about VR is that if I'm wearing the headset, and there's an instructor that can teach me and talk me through it, and there's a classroom behind me that's all watching first person on a large monitor what I'm seeing and what I'm doing. And then we rotate. You'll have a new student come in and do the actual task as the instructor is walking through. And people get excited about it. There are some obstacles, though, that you're going to face if you try to go down a VR path here. Cost. It's definitely more expensive creating full 3D renderings of a space and interactability than it is to, say, take a 360 video. The technical understanding, I still have every once in a while to explain what VR versus AR is. It's pretty common. How to implement efficiently, rapidly changing hardware, vendors, software. There's always something new and better and shinier out there. And the nuclear industry is pretty slow to change as it is. We still use a lot of pen and paper. So VR in general is an exciting new technology. I mentioned the HTC Vive. That's already 3 years old. That's old news by now. We need something new. You need the Valve Index or whatever's coming up after it. So we got ourselves some pictures of people using VR. This is from our FME scenario, where this is actually one of our training centers, one of our training instructors, and he is putting a mechanic through this FME scenario. And this was one of our pilot cases here. It was very well received at one of our nuclear sites. We had probably 150 people go through it. I guess I should start at the beginning though. So this was the very first pump room we made. It's the very beginning of what VR is. And really we wanted to teach people what VR can do. So we did a lot of these basic tasks, putting on a hard hat, confirming a valve and equipment tag, doing lockout, tagout, turning valves, checking things like that. And this is the room we created. It's very simple, fairly small, probably 20 by 20. We got pipes, we got pumps, we got valves. And we got that pump on the table there that we could show that you could do equipment maintenance with it. Got valves you can turn, dials you can read. And if somebody's in VR, the instructor can ask them questions. What does valve tag, 2 Echo Sierra Sierra Victor 212 Alpha say? What actually is it? And then they confirm what it is. We have to do a lot of 3-part communication to make sure that the wrong valve doesn't turn. So we can practice those kind of procedures and those human performance skills before we go into the plant. Really kind of a fun thing to do. So this scenario we built was just a lot of little things that we could show. So we have electrical, we have mechanical, we have operational things in here. This little pump here that we can take apart, you can do an inspection on it. So if you're an engineer who has never actually taken something apart, because when you go to school for mechanical engineering, for the most part, they teach you math, they teach you science, and you look up charts, and you try to find steam tables, that sort of things. You don't really get very much hands-on experience. So this pump here, maybe it has a crack in it that you're doing an inspection on, and you have to be able to find it and write up an issue report, cause a work order to go replace this sort of thing. If I'm an engineer and I'm brand new, I've never seen what bad looks like. I can show you what bad looks like. This one here is for you finish taking it apart, you can replace a gasket, put it all back together. Now this was shown hundreds and hundreds of times to, we had executives and managers, they loved it. They thought it was fantastic. They wanted to see more. So we made the updated pump room. This is more of a maintenance shop. It's bigger, it's better. And we have a horizontal split case centrifugal water supply pump. This pump is probably, $200,000 because it's a nuclear classified pump. And it's not very big, but we took the real pump that we have up at our 9-mile point station in upstate New York, and we made it in VR. We modeled you taking it apart, and we put it back together. So here's our room, and there's the pump. It's really not that big. It's probably only about this far across. And I've taken this pump apart in VR probably 10,000 times. I could do it with my eyes closed. If you gave me the real pump, I could do it. Everything but knowing how hard to torque the bolts. But you can learn that doing it any other way. And you could swap this pump out for any other pump. And I would much rather have you break my VR pump than my real pump because we only have one of them and it's a really expensive pump. So the amount of times I've taken this apart and you throw things all across the room and people have fun doing it. And you get the experience, the process of taking this apart and putting it back together. So you get that muscle memory, you learn the procedure and you do it repetitively. So as you can see there, you have your hand taking things apart, grabbing all the different equipment, it lights up. Maybe somebody else is telling you what that equipment is. I gave this demo to our rotating equipment specialist out at Byron Station. And he was so excited. He's like, oh, this pump here, and he started telling me everything I could possibly know about it because he's taken this pump apart 100 different times, this exact one. And he was saying, things we did right, things we did wrong, things that he loved about it, things that could be better. And he wouldn't stop talking about it as he went through it. And so you could take the whole thing apart and see how it works. And it's a huge positive thing that we've been using in our mechanical maintenance group now for taking pumps like this apart. And if you want to learn how it works, you can without having to touch the real thing. Notice here in this last picture, I'm lifting off the top half of the pump. The top half of that pump weighs 200 pounds. So in order to even try to do this in real life, you're hooking up a crane, you're getting everything done safely because you don't want to, pinch your fingers underneath it. And you're looking at, to do this whole pump tear down and put together, 2 days at least. For me in VR, I can do it in, a minute and a half and hit restart and do it in a minute and a half and just keep doing that. So there's a lot of advantages to doing things like that. The RP room, not as exciting personally. This was really the exploration of making a nuclear plant look and feel. And we also added in a working Geiger counter because we worked with our radiation protection department to see what do they want to learn? What can VR possibly be a benefit to them? And it's really hard to teach radiation because everybody here is getting exposed to some amount of radiation from space and from all sorts of other sources. But if you wanted to have a high radiation source in here, no, I don't want that to be in here. I want to be as far from radiation as I can, if you're getting an X-ray or things like that. So it's really hard to practice doing those skills. Well, in a video game, I can give you, I think it's the next one. So you got pipes and pumps and things like that here. We have our very realistic radiation step-off pads and low-dose areas. But I can give you a working Geiger counter. And I take this Geiger counter wand and I walk over to one of the pumps and pipes, and I find that, oh, hey, this area's got some high radiation that's not marked. So I brighten this picture up a little bit, but I put up a bunch of ropes around it and I put a sign up saying, hey, don't go over here, there's radiation. For some reason, it's unmarked. And this is how we would teach a new radiation protection technician. And in VR, it's very easy to do. In real life, very hard to do. As you can tell, my rope placement's not very good. I am not an RP technician. We also have pipe, valving, things like that. So mechanics, you can learn how to do things with this. Sorry, the pictures are a little bit dark. If you want to see more, you can come talk to me later. The foreign material exclusion. Now, if you've ever changed your car oil or you've ever worked on a motor, you got to be careful not to drop anything in the liquid, because otherwise it's going to get sucked in and who knows where it's going to go. Now, if you do that to a pump or a pipe that's got an opening this big, you could drop in a wrench, a hammer, your hard hat, something very large. Now, if a wrench gets sucked up into a pump, your pump is destroyed. It's a huge issue. In a nuclear reactor, there are pipes that if you drop the wire from a metal brush, it can actually damage the fuel. So we take foreign material exclusion to the extreme for good reason. So in our foreign material exclusion scenario, we just piloted it at our Braidwood site to about 150 individuals, all different people, got their feedback on it. So they have that sense of ownership as we go on to version 2 and make it better. And so there we have a big open pipe next to a hammer. We put people through this scenario and they had to, hey, there's a hammer here. Okay, what are you going to do about it? Why is this bad? And they were able to, identify all these work hazards that you may have found at the site. And some of these, a giant opening like that is glaringly obvious. Some of them were a lot more minor and you wouldn't notice unless you were a trained nuclear professional. And that's really what we want to get, is that questioning behavior, so that people are cognizant of the fact of what could happen if something goes wrong and how to prevent something from going wrong. And it was fun when we were going through these pilots. We designed it so that you had, there's a hammer next to an opening. Well, there were other people that were pointing out things that I didn't even know were wrong, such as on this one here, the rope that's holding up that sign is a braided 2-color rope. One of the colors of the rope is the wrong color. I didn't even notice, but they do. So the version 2, we fixed a whole bunch of little things that we're not intending to teach, but there's all sorts of things that people are going to look for in a scenario like this and try to catch and make, they're going to really know what they're doing. We have pipes that aren't covered when they're being worked on. And this scenario here is, we're rolling it out now to the whole fleet, which is 10,000 employees. We're probably aiming for around 100 a site to have gone through this training. Put the headset on, go through it, find these different things, have the discussion with the trainer to tell them what is wrong and what they would do about it if they found this in the site. We've given this training to one mechanic, and he just got straight up offended. He's like, you would never find my work environment ever looking like this. I wouldn't leave a hammer out like there. He was offended that I'd even suggested he might, which is a good thing. Now when it comes to nuclear power, we are a very old industry. Everything we have is built probably in the 50s to 70s. To me, that's old, at least. I'm a pretty young guy. And if you look at all of our prints, all of our blueprints, it's pencil on paper. It's been scanned in, but it's non-digital. It's not CAD files. So all of our as-built, it's kind of a guess. You have to go out there and you got to go look around. If I want to know how 9 Mile Point Station is built, I got to fly to 9 Mile Point and look around or take a picture or hope somebody out there will take a picture for me. So we're in the process of laser scanning the entire facility. We're going to get as-built, millimeter accurate measurements of everything. And you got a whole bunch of other uses, project management, engineering that you can do with these things. And we're building the entire station in VR. We're turning it into 3D models so that when we have it in VR, we can do anything we want with it. So those pump rooms, let's do it in the real site. We want to practice having an operator do his rounds and talk about this gauge and that gauge and you got to read it. We can do that. You want to add in, let's say, there is an emergency, there's a fire that breaks out on the turbine deck. What are you going to do about it? Where's the fire extinguisher you're going to get? Where are you going to run the hoses? Well, let's go do it in the real place. Heck, let's even put a fire in there. Let's have smoke fill the entire room and make it as real as we can. And how are they going to react? Because the higher fidelity we can make it, the better. So here's a picture of, this is Ginna Station, also in upstate New York. It's a bunch of pipes, a bunch of valves, some electrical equipment on the wall. You got the red fire retardant up on the top. And here's a laser scan. It's, again, really messy. Here's a 3D model of that laser scan, if you convert it directly. Turn it into a 3D model, put in some color, and you're able to walk around this space now in VR. Here's what it really looks like, and here's the 3D model. I mean, I can go back and forth a couple of times, and you're going to try to look and pick out the little differences. But that's the level that's necessary. If you give this to anybody who's familiar with this site, well, they know exactly where they are. They're on the 737 elevation on the north end of the turbine building, second floor. Like, of course, that's where you are. That's what it's a picture of. But even though this is a 3D rendering. And we did doing that for the entire site. So I only got a couple minutes left, so I did say there will be a test. It's not a hard test. Is nuclear power safe? Yes. Is it clean? Yes. Should you support it? Yes. Is wind and solar good too? Yes. And if you have questions, can you ask me? Yes. I was going to put some really difficult math questions on there, but too much effort, so. That is actually all the presentation I have for you. I got a handful of minutes left. Do I have any questions? I realize I tried to cover as many things as I could, so yeah, we're right up front.
So going through this, and I love your implementation of it, balance between VR and AR. So I like test check two. There we go. Noah. No, I'm kidding. So I'm William Harding from Medtronic, and we're medical device manufacturing. Mm-hmm. So I like your implementation, what you've done. I'm not married to either VR or AR, so I'm perfectly fine with that. But basically, thinking about it, it seems like it would be easy to implement and so on down the line, but there had to have been a lot of political and business barriers and obstacles you had to overcome to get this really sold to people. Can you speak to a couple of those and kind of lessons learned from that?
So that very first pump room we made with one of our vendors, we got a small budget to do it. And it was a lot of show and tell to executives. And you say, hey, just kind of go with me on this and put this on. And you kind of, it's kind of, I feel like an internal salesman. I mean, you know, the VR evangelist in me is I'm talking about all the things that you could do with it, all the things that we could use it for. And a lot of our senior leadership, you know, they're very forward thinking. We have been talking about innovation a lot over the past couple of years. And they go, oh, well, can you do X, Y, and Z with it? And the answer is yes. Now, you mentioned AR and VR. For us, VR is very heavy in the training world because you can practice doing skills. AR, to me, more of is the operations side of things, when you're actually doing a task. We have to be qualified before we can actually do in the plant. So that's kind of why I see such a strong divide there. We would not give somebody a job task that they don't know how to do with some AR glasses of some type and say, just go figure it out. That's not okay for us. So, thank you. Other questions?
Sure. Hey, I'm Sohail Fatih, and I'm a virtual design engineer at Clark Construction Group. Mm-hmm. Besides the trainer training the trainee, I would assume the other way around is also valuable to you guys. So the feedback data that you would get from your trainees being trained in your virtual reality environment, how do you make use of that data, and how do you like improve your training system based on that data? Like what kind of analytics you would use for doing such thing?
For the FME scenario, we did a pilot at Braidwood, about 150 people. And when we talk about nuclear, we always describe the term, we are a learning environment. If anything ever goes wrong, we learn why and we fix it so it doesn't happen again. Feedback is required for every training course. So every of those 150 people we put through, we had them fill out a sheet of paper, answer 1 to 10 on a bunch of different things, ask them what they can add to it. We were taking notes the whole time. We had probably 4 instructors in there. I mentioned that rope being the wrong color. Of course, we write that down and we record it. We make sure, because that is extremely valuable. Because if I just give somebody a new tool and say, hey, go use this, it's great, it's not going to get used. We've tried that before. It's not a good approach. You have to have somebody that goes, oh yeah, I was in part of the pilot of this. This is interesting. I want to be a part of it. I had some say in the matter. And that's very, very important. And then they get excited about seeing the next one. And then they recommend, can you do X, Y, and Z? 6 months later, they're here, we're working on Z. Oh, this is fantastic. I was the one who gave them that idea. And they get excited about it. Feedback is very important.